Okay, so for this question, they're asking us how can we possibly get this shape to be here? And you might be saying like, oh, it looks like we can reflect it a couple times. And you're right, you could reflect it a few times. But of our selections for reflections, it's only reflecting it once across the x. So for part C, if I reflected this across the x-axis, it would look, so like take this point, 1, 2, 3, 4, 1, 2, 3, 4. So that one would be here. This other one would be here. Looks like this one would be like this. This other one be like this. So our image would end up somewhere over here. So that would not be C. Same reasoning for kind of like for part D. If I just reflected over the y-axis, my image would just go somewhere over here. So we're not quite getting there. So our answer is not D either. Part B, yeah, you can translate it this way and go down, but translate means you're not turning the object or flipping it, so it literally look the same exact way as it does, so it's not going to look the exact same. So the answer is actually A, and you can kind of prove this to yourself. If you click on this, actually I'll make a little diagram here. Keep the ink there. And if I rotate this 180 degrees, you'll see that that object actually fits on there. So it has a 180 degree rotation. So that is A. Number 2 says triangles ABC and triangle DEF are graphed. Which sequence of transformation will make ABC go onto DEF? So reflection over the x-axis followed by reflection over the y-axis. So this point would go here, then here. Okay, that adds up. This point would go 1, 2, 3, 1, 2, 3, then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, so far so good. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, then 1. Boom. Looks like that one would work for part A. Let's see, what else might we be thinking here? A 180 degree rotation followed by reflection. So actually the 180 degree rotation is enough. Like that's all you need to do is to rotate that and it would actually fit onto it. So the reflecting over y equals x, which this is the line y equals x. Like if you graphed y equals 1x plus 0, that's y equals x. So you're rotating it and then flipping it. So you don't need to do that. It's just the rotation would be fine. 90 degree clockwise rotation about the origin followed by reflection over the y-axis. 90 degree rotation would make this thing go over here, and then flipping it over the y-axis would get it back to around over here. Translation's 8 units to the right, 1 unit up, and then so this would go like all the way over here, and then you're kind of rotating it. You may land it somewhere around here, but if you only rotate this thing like 90 degrees, it's not going to be enough to have this face pointing in the direction that it is. It's like this would have to be a 180 degree rotation. Number 3, you could graph this one, but also something interesting that you can notice is that old A to new A, old B to new B, all of their X values are flipping. And it looks like their Y values are staying the same. So that should lead you to figure out which one it is, but if you don't, let's just graph a few of these really quickly. Let's graph the A's. Oops. -3, -1, that's old A, and then 3, -1, that's, so this is A, new A, and then -6, -5, just kind of sketching out where it would be. This would be old B, and then 6, -5 would be new B. So this is actually reflecting over the Y. Like you're taking these and flipping them over here. This would be a reflection over the y-axis. So if you graph them, I think it actually helps you out if you haven't been doing that. Triangles. Alright, so we have a translation. So what that means is you're taking a triangle and just kind of moving it 4 units to the right and then 6 down. So all you need to do is the actual translation rule would be like x plus 4, because to the right is positive 4, and then negative 6 for the y, so then y minus 6. So let's look at a. A, this is the x value, this is the y value, so negative 7 plus 4, 6 minus 6, so this would be negative 3, 0. That should be the new a value. Negative 3, 0, and boom, there it is. You could, if that didn't make any sense, you could graph this and then move each point, but I don't know if that makes any sense. So you could graph this point here and move it 4 right, down 6, you'll end up at this point, and luckily there's no other choice that has negative 3, 0. So each cube was numbered so that opposite faces have a sum of 7. So that means 2, and whenever the number is over here, which should be 5, right? I have to add up 7, like 3, whatever the number is over here we can't see, should be 4. So it says, which transformation did Ken use to reposition the cubes from figure P to figure Q? Okay, so reading the choices, it looks like it's rotate top cube, rotate bottom cube. That's all of them. So what's kind of a giveaway for the top one is you see the 6. Now the 6 looks like this. So it looks like they went 90 degrees clockwise. So top cube, looks like that has to be your answer. But let's see what else we can do to prove this. It says also rotate the bottom cube 180. So if I rotated this one 180, the 2 would be over here, and what number should be here? 5. So the 5 would then come over here, and that's what you see. Same thing with the 3. The 3 disappears. What should be on this side? The 4. So that adds up. Which figure shows one onto the other? I think the question's kind of a little weird. One triangle. We don't see any triangles, so I guess what would map this shape onto this one? Well, let's look at, maybe you're thinking, what is a glide reflection? So let's skip that for now. A reflection followed by a translation, and then we got 2 translations. Well, if we're starting with this one, I know we're starting with this top one because it doesn't have the apostrophes, so this has to be the image. If we have 2 translations, no matter how you move it, this object has to look exactly the way that it is. So this one got flipped or turned around or something, so it's not going to be the 2 translations. Yeah, I apologize for this question. I didn't make this review. So, it says one triangle. Well, like A and B are both possible. So a glide reflection is a reflection and translation, just like B. So, what I was looking at here is what if we reflected this one across like a horizontal line? You would get what you have in the diagram. Like you would have this, and then you could just translate it and move it over. So I think A and B are okay. A rotation won't work, because think about if you're rotating this one around like that, right? This piece, if you're moving it, would be in the front, so it would end up over here. Or if this piece, if you're moving this one around over here, this front should be over here. So it wouldn't be those, but A and B are possible answers.